Hello, now I am going to solve numerical problem 8 and 9. So this is the problem here, transform a vector into cylindrical coordinates. So let us consider the cylindrical coordinates of a given vector AR, A phi and AZ. So we know that vector AR equal to vector A dot unit vector AR. So we have this vector Y unit vector AX minus X unit vector AY plus Z unit vector AZ dot unit vector AR. Now dot product inside the bracket, you will get Y unit vector AX dot unit vector AR minus X unit vector AY dot unit vector AR plus Z unit vector AZ dot unit vector AR. So after solving this, and we know that the value of vector unit vector AX dot unit vector AR is Y cos phi minus X sin phi plus 0. It is equal to, we know that the value is rho sin phi cos phi, rho sin phi cos phi minus rho cos phi sin phi plus 0. So this term will be cancelled out and it will equal to 0. So AR vector is equal to 0 here, and now we have to calculate A phi. So A phi will be calculated in same way, vector A dot unit vector A phi. So here we have this Y unit vector AX minus X unit vector AY plus Z unit vector AZ dot unit vector A phi, and it will be equal to Y unit vector AX dot unit vector A phi minus X unit vector AY dot unit vector A phi plus Z unit vector AZ dot unit vector A phi. So it will be equal to minus Y sin phi minus X cos phi plus 0. And we know that the value here, the value of Y is rho sin phi, so it is equal to rho sin phi and sin phi minus X equal to rho cos phi, so it is rho cos phi and cos phi plus 0. So it will be equal to rho sin square phi, rho sin square phi minus rho cos square phi plus 0. Just take this rho outside and it will be equal to cos square phi plus sin square phi, which is equal to minus rho. So here we have the value of vector A phi is equal to minus rho. Now we have to calculate AZ. So AZ will be calculated in same way, vector A dot unit vector AZ. So this is y, unit vector AX minus X, unit vector AY plus Z, unit vector AZ, dot product with unit vector AZ. So it is equal to y, unit vector AX dot unit vector AZ minus X, unit vector AY dot unit vector AZ plus Z, unit vector AZ dot unit vector AZ. So now AZ is equal to, we have, this is AZ is equal to Z. So A will be equal to AR, unit vector A row plus A5 and unit vector A5 plus AZ, unit vector AZ. So it is equal to 0 plus minus row unit vector A5 plus Z, unit vector AZ, and A equal to minus row unit vector A5 plus Z, unit vector AZ. So this is the problem of this equation. Now this is numerical 9. A vector A in cylindrical coordinates is expressed as A equal to 2 cos unit vector A row plus 3 row unit vector A5 minus 8 AZ. So transform this vector into Cartesian coordinate system, and I will continue this numerical in next talk. Thank you.